All right, Physics 30s, I'm just going to go over this Physics 30s. I'm going to go over this worksheet that we have here on curved mirrors and the formula for curved mirrors and how do we solve questions involving these, getting attributes and stuff. So just remember that we have the two formulas that we're going to deal with most of the time here. We're going to have 1 over f is equal to 1 over do plus 1 over di. Then we got magnification, which is hi over ho is equal to negative di over do. Okay, so those are the two formulas that we'll be using for most of these here. They're going to help us determine characteristics as well. So an object is 4 centimeters high. It's located 10 centimeters in front of a concave mirror. So that means it's going to be a positive focal length. Hopefully it's going to be positive. If we don't get positive out, then maybe the question's wrong. We get an image that is erect. So that means it has a positive hi. The virtual image, so that's a negative do, and is 5 centimeters higher. So it's a little bit larger than the previous one. What's the focal length of this mirror? So to find the focal length of this mirror, we need to find di. We know it's virtual, but we don't know the actual distance because we know what do is. So there's do, right? The 10 centimeters. This is ho here. And this is hi. Hi, yeah, it's erect, so that's positive 5 centimeters. Okay, good. So we're going to use ho and hi to help me find di using the second formula here. So the second formula says hi over ho is equal to negative di over do. So I'm going to put in the information we have. We got 5 over 4 for that side. And I want to find di, so I'm going to go negative di, and then on the bottom I have 10. So we're going to do the quick little calculation here to find out what di is. Di will end up being negative, so I didn't have to tell you it was negative, virtual, but it just ended up being that way. 5 over 4 times 10. It's 12.5. Okay, so I know my di is negative 12.5 centimeters. Okay, now the next part of the question says, okay, what's my focal length? So I'm going to put into the formula my object distance of 10 centimeters, my image distance of negative 12.5, and we're going to see how that works out here. So we have 1 over 10 plus 1 over negative 12.5. I'm not going to go through the whole calculation. Actually, I'm going to show you this part at least. And then f is going to be 1 over that number, 1 over this number, which is 1 over f, so 50. So my focal length is 50 positive, which is nice, 50 centimeters. There you go. Let's put the positive there. Emphasize that that's a positive number. Cool. Here we have an object that's 7 centimeters tall. I'm just going to put some of this information on the side here that we're going to use. It's placed 4 centimeters in front of a convex mirror. So that's a negative focal length here, but do is 4 centimeters. It has a focal length of 8 centimeters. Okay, so that means we know it's negative 8 centimeters because its focal length is convex. I calculate the image distance, the height, the magnification, and any other characteristics. Okay, so it seems a pretty legit question here. So I'm going to go 1 over f. So I'm going to go 1 over do plus 1 over di. Oops. And we're going to find di first. So 1 over di is equal to 1 over f minus 1 over do. We'll put in the information that we have. 1 over f is negative 8 minus 1 over 4. Hopefully get, because what we know about convex mirrors is that they're always going to be virtual images. So I know that I'm going to get a negative answer here. Get 1 over my answer there, so I get di to be negative 2.67 centimeters. I'm going to keep it 3 sig digs, but I have the 6 repeating in my calculator for further calculations. So there's one of my answers. Okay, the magnification might be useful to find the height as well. But since we know the di, which is negative, the magnification formula is negative di over do. I don't know if I put a negative inside that. It's negative. There's going to be a negative eventually. So I'm just one second. I don't know why that's in parentheses at all. Negative, so this is 2.666 repeating here, divided by my DO of 4 centimeters. So I get a magnification of, I can put this in a fraction too, of 2/3. That's my magnification. And it's a positive 2/3. That's going to tell me something about my characteristics. Then I'm going to use that magnification to find out what my HI is. So it's my magnification times my HO times by 7. My HI is 4.67 centimeters. Nice positive number too. Okay. So I got all my numbers and everything. So let's look at my characteristics. So we got a positive magnification. So that means we know it's erect. If you want to use the word upright, that's fine by me. Okay. It's a negative DI, so that is a virtual image. And what else do we have here? Oh, it's 2/3. 2/3 is 0.6. So that is diminished. Okay. I'll just put down here, since the magnification is less than 1, right? It's virtual because DI is less than 0, so it's a negative number, and it's erect because a couple of different ways. We can say magnification is a positive number. There. You don't have to put the since parts in there. You can just give me the characteristics. Okay, an object is placed 8 centimeters in front of a convex mirror. There's a radius of curvature. Now, radius of curvature is from the mirror to the center. So remember that the focal length is always half that distance. So it's convex, so it's -4 centimeters. Convex means negative again, right? So, but it's half that radius of curvature, so that's half of the 8. Okay. An object is placed 8 centimeters. So they just happen to have 2 8s here, but DO is 8 centimeters. Well, that's on the center point. That's a magnification of the image. Okay, so let's find out what the DI is. I'm going to assume that's going to be the same as the DO because that's what we've discussed before. But we're going to use this formula. Figure that out. So 1 over -4 is equal to 1 over 8 plus 1 over DI. That's kind of a weird way to do it. I usually rearrange first. 1 over DI is equal to 1 over -4 minus 1 over 8. I think that's right. Yeah. So what is DI? Let's figure that out. Oh, it's convex. Oh, that makes more sense now. So it's not going to be the same height. That's fine. 1 over -4 minus 1 over 8. Then I'm going to go 1 over my answer. Oh, 1 over my answer. And I get a DI of -2.6. Repeating again. So this is centimeters. That's not the question. The question is magnification. I want negative DI over DO. So my magnification is going to be -2.67. There's more decimals than that, but I'll put it in my calculator here. So my magnification is 1/3. Remember, negative turns positive. That's my answer. Cool. An inverted real image of a 6 centimeter tall candle object is found to be twice as tall as the actual calendar. So what we know, if this is the case, it's inverted. So we know HO, 6 centimeters. It's twice as tall So it's 12, but it's inverted, right? So it's that part. The candle is 15 centimeters in front of the focal length mirror of a focal length of 10. Calculate the image attributes, the characteristics. It doesn't tell me what kind of mirror it is. So maybe we have to figure that out, because we got some information about what kind of image it is, the positive number, right? So it's what we know about the DO. I don't know why I wrote HO there. DO is 15 centimeters. So I can use the magnification formula to find my DI here. So I can use the find my DI. Now, I probably didn't need this focal length of 10 centimeters to help me figure this question out. I don't know why that's even there, because I can find my DI otherwise. So let's do that. So negative DI over DO is equal to HI over HO. So I'm going to put in my information here. So I got negative DI over 15. Got negative 12 over 6. Yeah. Okay, so I'm just rearrange this. So you got 30. So DI is positive 30. So that confirms that this is a real image. That's good. So we figured that one out. Determine the characteristics. Calculate the image height, which we did already. The image distance, which we just did. So we got both of those pieces. So that's done, and this is done. Determine the characteristics of the image. So we already know it's a real image. We know it's inverted. The only thing that we have to do now is it's enlarged. That's kind of weird. Now, a good question for this would be, what kind of mirror is this? So I'm gonna actually find out what kind of mirror this is. Is it a concave or is it a convex? So I'm just going to go through and plug in some of the numbers that I have here. 15 plus 1 over 30. Most of it's going to be a concave. Yeah, it ends up being positive 10 centimeters. So it's concave. Concave, remember positive, focal length, concave. Now that didn't ask for that question, but I think that's a better question to ask for this, because they already gave you pretty much all of the characteristics of the image already. So that second question is not very nice, or very easy, or too easy, sorry. Let's see, we have a 5 centimeter tall object. Produces an image that is 7 centimeters behind the mirror. So behind would be like a virtual image, so I'm going to say negative. The radius of curvature of the mirror is 10. So because of that, this is going to be 5 centimeters. And they're going to ask for what type of mirror this is. So I want to figure out, is it a plus or minus? So I don't know which one of those two pieces it is. Calculate the magnification and determine the type of mirror used. So this is a tricky question. So how do we think we're going to do this question? Okay, so to do this question, what we know about the DI, and what we know about virtual images. What do we know about virtual images and what do we know about DIs? Okay, so I'm gonna look at some logic here to do this question. So I'm gonna look at this formula to figure out what we know. So HI over HO is equal to negative DI over DO. Okay, so what we know in this, we don't know too much about this, but we do know that this is positive 5 centimeters here. And DO is always a positive number, but we don't know what that number is, so it's going to be important that that's positive. Now we also have negative, 7 centimeters. So that top part turns to be positive 7 over a positive number. So this side of the equation is positive. So to make sure that the other side of the equation is positive, this top, the question mark, must be positive. Right? Make sure everything's positive. So we know the HI is a positive number. Okay, but we don't know exactly what the number is, but we know it's positive, okay? We know, okay, so let's go through some of the math here to figure out, okay, do we know the focal length? Is it positive or negative? So we know this much so far, so I'm just gonna cross that off for now. I'm gonna look at the other equation and think of this logically too. So we know our DI, but we don't know our DO. I'm just gonna put the two equations in there. So this here is positive or negative. Fine. We don't know that much. We don't know DO. I'm gonna put a little, just put a question mark there. And we know DI is a negative 1/7. Okay, so the key is that DO has to be a positive number, right? So this, we know this piece has to be positive. Okay, so if that was a positive number, okay, so if that's a positive number, what would it have to be? So we're going to do the math. We're going to do the math twice here. So I'm going to add over 1. I'm going to add over the 1 or negative 1 over 7 here. So it's going to have 1 over plus or minus 5 plus 1 over 7. So by adding over, it becomes a plus there. I'm going to do the math twice. So what's 1 over 5? Well, 1 over 5 plus 1 over 7 is a positive number. Okay, so that's going to work. But does 1 over negative 5 plus 1 over 5, 7, give me a positive number? Let me try that. So it's 1 over negative 5 plus 1 over 7. That is a negative number. So this doesn't work. So I'm not allowed this. I'm not allowed to have a negative DO. So this can't be a negative focal length. So that means this focal length has to be positive. So I'm going to write that in here. Focal length has to be positive to ensure DO to be positive. Okay. So that means my focal length is positive 5 centimeters. Okay, now we can do a bunch of stuff here. We can determine, we know what type of mirror it is, so it's positive, so that means this is concave. Awesome. So we know it's concave. Now we want to determine the magnification. That means we're going to have to find the DI. So if I know that this is positive 5, if I add over the 7, I can get the DO. Oh, we have to find the DO, sorry. We know the DI. So 1 over 5 plus 1 over 7. 1 over my answer. So my DO is positive 2.916 repeating, so I'll just put 2 for now. And then we can use the magnification formula, negative DI over DO. So negative 2.9166 repeating. And what's my DO again? Oh, I got this the wrong way. That's my DO. My DI, sorry, is negative 7. My DO is 2.96. There we go. So 7 divided by this answer. So I get 2.4. So magnification is 2.4 times. Oh, that was a tricky question. It's a good thing that I didn't ask that on the assignment. Okay, see you in the next video. Bye.